Hello friends, welcome to Hidden Layer CI. Today we are going to cover color spaces. Let's check. We'll cover some concepts first before getting into the code so that we have fair idea. So there are different types of color spaces are there. So famous two are that RGB and BGR. RGB is generally used in many places and OpenCV uses the BGR, so that we need to remember that. So RGB stands for red, green, blue. So its value actually starts from 0 to 255. So it can store in a byte. So if you see this one, you can also represent the entire this value range in the form of cube. So when all RGB values are 0, that means it is showing a black color, and 255, 255, 255, that makes the color white. So you can see that visually white color is at the spot, and it is actually at the bottom of the back side of this white spot. If you visualize it, that will be 0. So from 0 to 255 the red. Similarly, this corner greens 255, this corner 255. So you need to understand this. OpenCV uses the BGR. What it means is, when an image is formed, there will be three panels of colors. The first panel is going to be B. B stands for blue color here. Whereas in another libraries, Matplot library, for example, we will use RGB colors. So if you wanted to convert from BGR to RGB, in the OpenCV we have a CVT color. You can give it an image name and a constant, which basically says that convert BGR into RGB. So once you convert it, then in that RGB image can be shown using a Matplot library with a properly. Otherwise it will show different. Let's see how it works. Some concepts. So this is the colored image. So basically you can visualize it as a collection of three panels: red color, green color, and blue color. In our coding session, we will actually split this colored image into three panels, and then we'll show how they do look, because each panel has the values from 0 to 225, and it is two dimension only, not three dimensions. Hence it will look like some gray color images. To show the really red color how much it is there, what we can do, we can take it of this panel and add two empty panels like 0 panels. So then it becomes the full red color. RGB, but B and G will be zeros, so it becomes a red panel, and you can show that in the in our applications, right? So we will also show that in a code. One thing we need to understand it. This is the yellow color, which is generally made from red and green. You can also observe that here is more green and red, and whereas the blue color is very less. So makes sense. So this yellow color is being split between the red and this. Now we are going to, once we have this color panels, we can actually create a gray color image, but there is a industry standard to create a gray color images. So that is actually, they take the 30% of red color and 59% of green color and 11% blue color. They mix together and to arrive this gray color. In generally in OpenCV, CTV color is there. You can give an image, and you can also select the BGR to gray color. So it will automatically convert. But internally, this will be mixing those panels and then creating a new image and then returning it. Now let's see the another model. HSV or HSL. HSV stands for the hue, saturation and light or value. This is not a cube form, but it is more of a cylindrical form. So the hue stands for color. Basically it is across the entire circular form. Its value starts from 0 to 179. Okay, and whereas saturation starts from the center of the pillow and it moves towards the outer side. So it will be 0 and this will be 255. And value is also starts from 0 bottom and then increases to 255. Basically the advantage of this color model is one can easily select the colors easily, that is one, and then it can be easily understood by humans, because when you compare with RGB, when a specific color is been taken, it is always a combinations. Here you don't need to think like that, because the color can be taken out from the hue color itself. And then saturation and light is nothing but how bright and how dark it is, how saturated and how bright and how dark it is. Saturated means the color is fully pure color. For example, if you see this one here, the lighter color will be there, whereas this one is a darker color, so the color saturation is increasing this side. So that is what we will see in the code actually. Let's see. So first step is we'll just display this image and see how it looks. So for that you give the file name and then read the file and then show that image, right? So you can just display that one. Here is the image, just we are showing the original image. Okay. Shapes, first we will read this image and then display this shape, and it will be 3 dimensions. Then we are splitting this one. This is where the function split, it is OpenCV function, takes an image and split into 3 2 dimensions panels, and then we will see its shapes as well. You can see this original image is 406, 455 and 3 channels are there, and we are returning these values: blue color, green color and red color. It is a 2 dimensions data. Now let's see, we will show this in the form of image pictures. So you can see this is the blue color, green color and red color. So more white is there means more red color is there here, because 255 is what actually represents more white, means more red. So here more red is there, here green is there quite a lot, but it is not like as much as red, and blue is quite less. Now that we have a panels, what we can do, we can create some empty panel like this. This is the same size as that. We will merge this panel with the retrieved panels, the colored panels. To create a blue color panel, we use CV merge function. So since it is a BGR model, we will give the blue color panel that we have received and then 2 black or empty images that we are attaching. Then it will become BGR model, and then once we merge it, we can show in the OpenCV itself using a IMSO. So this is what it is we are doing here, and same thing is applicable for green panel. You need to understand that green is at the center, red color is at the corner. So let's display this one. So you can see this is green color which we have retrieved from the original RGB three colors picture, and now we are able to see that as a panels. In the next step, what we are going to do is, since we have already collected here, we are going to show the image in the directly first, and then we will merge those color panels and show the same thing in the IMShow, but we are using the Matplotlib library which uses the RGB model, not OpenCV, and we are going to put this. So basically I am showing that the same image is being displayed using the OpenCV, and then panels have been remerged and showing into the Matplotlib library same image, and so there are two titles are there, so we can distinguish. So this is displayed by OpenCV, it's a BGR model, and this is the RGB model, but it is a Matplotlib library. They look same. Now we'll see how the gray color images have been formed. Basically we will use BGR to gray color and using the OpenCV, and then we will display one. Then using the formula we will recalculate from the panels 30% of red, 59% green and 11% blue, and this image has been, this image has the fractions, so it is better to convert into byte type. So this is how we are typing as type, so you will get all the image with the bytes. So this we are going to show using a OpenCV. So this is basically using the standard API that they have. This is manually we have created. Mostly this function will use the similar concept internally. Let's run it and see. You can see this is also gray. This is the OpenCV CTV, and this is what we have manufactured. This is what we want to cover in this session. If you have any questions on this code, or you can put questions in the comment box. Please subscribe to my channel, Hidden Layers AI. Thank you very much.